When people think of the word xeriscape, they think about landscapes that are spiny and spare, but it doesn't have to be that way. Water-efficient landscapes can be lush, they can be green, they can be functional, and they can really be aesthetically pleasing. Hi, I'm Kelly Cope, and today I'm going to be talking about resource-positive landscapes. I'm a professor in the Plant, Soils, and Climate Department at USU, and also an extension specialist in water conservation and turfgrass science. In this Research Landscapes, I will tell you about resource-positive landscaping, how my research on turfgrasses can help people conserve water and still enjoy a green and beautiful landscape, why it's a mistake to remove lawns for the sake of conserving water, how homeowners, home builders, and local leaders can support resource-positive landscapes in their communities. So one of the main reasons that I've chosen to focus my research on grasses is that if you add up all of the land area in this country that is covered with grasses, it is the largest irrigated crop we have. So if we want to save water, there's a huge potential for managing that land appropriately. Some of my research areas include essentially mini landscapes. They have grass areas, they have small trees, they have perennials and shrubs, and they really mimic a home landscape. The research landscapes that I have at the USU Botanical Center in Kaysville are actually built in something resembling a swimming pool so that we can contain all of the water that is applied and we can collect all of the water that leaves. And we're interested in testing the water that leaves these landscapes because we can see how many nutrients are in that water, whether there is a pollution concern, and whether a lot of water is lost due to over-irrigation, for example. I love this picture. It was taken years ago in the landscapes at the USU Botanical Center. We had citizens come and give us their opinions on the landscapes. And these landscapes could contain different grasses. For example, some contain Kentucky bluegrass, some contain tall fescue, some contain buffalograss, in addition to other landscape plants, perennials, trees, shrubs. And we had them evaluate the landscapes when they were really well watered, growing well, really green, really lush, and then we turned the water off for 6 weeks, and we had them come back after that. So it was really interesting because the Kentucky bluegrass had gone completely dormant when they came back after we had stopped irrigating, but the tall fescue had stayed green. And it didn't matter what the surrounding plant material was, whether the flowers were blooming, whether the shrubs looked wonderful. All the people cared about was how green is that grass. I know it sounds simple, but if people really want green grass and we want them to conserve water, we need to do both. And that's what my research does. I'm very fortunate to be associated with USU's Center for Water Efficient Landscaping. The goals of the center are to extend research-based information to the citizens of the state so that citizens can have landscapes that appeal to them and function in the way that they need them to, but still conserve water. In the West, we think about water that is something that must be saved, something really precious, almost like gold kept in a safe. In my research, I conceptualize water as a tool, something that can help us optimize the benefits from the landscapes that surround us, not something that we have to hoard. So, thinking back to 2015, California was in one of the worst droughts in its history, and agencies and cities were trying everything they possibly could to save water, and actually implemented a lot of turf removal programs. So there were some unintended negative consequences when turf grasses were removed in California. Look at this slide. You can see real differences in temperature across water, air, sand, grass, asphalt, and synthetic turf grass. Temperature differences ranging from 94 in the case of the air to as high as 165 degrees in the case of the synthetic turf grass. The cooling effect that happens when structures are surrounded by plants was lost. The energy that was required to cool those structures as a result actually resulted in more water use. And water is a critical part of energy production. Nuclear and coal plants use water to turn steam turbines. Obviously, hydroelectric power requires a lot of water, and water is even required to clean solar panels. Grasses provide a number of ecosystem services in our landscapes. I've mentioned the cooling that they provide. They also serve as biofilters for pollutants that may come in the form of atmospheric deposition or perhaps in our precipitation. They can also keep stormwater on site, which you'll hear more about from Daniela Hirschfeld. And they can sequester carbon, of course, like other plants in the landscape. They also function as virtual reservoirs. Utahns are used to irrigating lawns on a regular basis. And in times of extreme drought, that irrigation can really be reduced, making lawns function almost like a virtual reservoir. And here's a clip of Daniela Hirschfeld talking about how turf grasses and other materials can help communities with stormwater management.
So when we have all of our surfaces being paved, the water runs very, very quickly, and it runs into the community stormwater system. And communities are responsible for paying for dealing with that water. I'm Daniela Hirschfeld. I'm a professor of environmental planning in the Landscape Architecture and Environmental Planning Department at Utah State University. And I want you to start by picturing a driveway that has just normal pavement on it. And when the water hits that driveway, it runs off and enters into our stormwater system. If we were to change that driveway, you could put a patch of grass on it in between where the tires go, or you could use something called permeable pavers. And in that context, when the water hits the surface, instead of running into the stormwater system, it infiltrates into the groundwater system. The surface is acting like a sponge, and when the water falls on it, it goes into that sponge and it very slowly seeps through the groundwater system and eventually reaches our streams. So if you can kind of imagine water flowing through a sponge, every time it touches a surface, some of those pollutants get removed from it. It also gets removed because as water moves slowly, heavier things drop out of the solution. So if you think of water moving quickly, it's carrying materials, and when water moves slowly, those materials are literally being dropped out. So some cities are adopting stormwater ordinances. These are special ordinances that charge citizens additional money for having more impervious surfaces. They're encouraging the use of pervious surfaces in your landscaping to reduce the amount of water that the city has to treat. So in our backyards, it's really important that we have a variety of habitats and a variety of plant species, as well as permeable surfaces, permeable pavers, and we want to make sure that we have water-wise plantings, such as a water-wise turfgrass.
So I get one question more than any other, and that is, what kind of grass should I plant? So the challenge that most folks have when they look at a bag of grass seed is they really don't know what they're getting. They may not know the varieties they are getting. They may not know what sort of research has been conducted to see how well those varieties perform in their local climate. And in addition, depending on where you're shopping, the same seed mixture can be available in all parts of the country, and that's not necessarily appropriate. And we help folks deal with that by trialing different varieties here in the state of Utah and then making that information available to the citizens. So which species work best, which varieties within those species work best, what's going to help them save the most water. So what you see here is a number of plots, all Kentucky bluegrass, but you can see that they are responding very differently to drought conditions. Some much better than others, but this just really illustrates well how differently different varieties can perform. If I was helping you choose a grass for your home landscape, I would treat it almost like a detective job and ask you a lot of questions about what it is you plan to do with the grass. Do you have children? Do you have pets? Do you enjoy maintaining it? What sort of resources do you want to put into it? And what sort of resources do you want to get out of it? Now I'm going to talk about 3 turfgrass species that are commonly seen in the state of Utah. But keep in mind that even within those species, there are hundreds of varieties available. Kentucky bluegrass is used the most in this state by a long shot. And there are good reasons for that. It is a grass that can really take a lot of traffic. It performs well in parks, does great with kids, does great with pets, really has a place in our landscapes. Historically, though, varieties that we've used have been higher water use. But something that people don't necessarily realize about bluegrass is that while it can use a fair bit of water and even enter dormancy pretty quickly, it recovers from drought better than just about any other grass species that we use. Tall fescue is another grass that we can use here in Utah that performs very, very well. It has a slightly lower water requirement than Kentucky bluegrass, but what differentiates it from bluegrass is that it roots very, very deeply into the soil. And that's important because it can access soil moisture very, very deep underground. Tall fescue is still a great choice for lawns where you've got kids and pets playing. The color is very, very similar to bluegrass. In fact, most people can't tell the difference just by looking. Buffalograss is a more unconventional choice in the state, but does very, very well here. And it's a warm season grass, which means it does better in the warmer times of the year. And it has a significantly lower water requirement than either bluegrass or tall fescue. It's unconventional because it's just not used as often. And also, it has a different color. It's more of a gray-green than a blue-green like you would see with bluegrass or tall fescue. So it looks really different. And in addition to that, it has an extended dormancy period in the spring, and it goes dormant more quickly in the fall because it really prefers those warmer temperatures. You might choose to mix these and have great success with that. For example, mixing bluegrass and tall fescue can help you cover shady and sunny areas, as well as providing some resistance to environmental stressors, be they insects, drought, heat, etc. There was a time that I lived in Smithfield, and I lived in a house that was well over 100 years old, and the lawn was actually about 50 years old. And it was still doing fine, it was growing okay, but it was a really old variety, tended to require more water, and so I did some work to replace that with a newer variety that was water conserving, greener, more lush. I'm not suggesting that everyone rip out their lawns. What I know is that if everyone could irrigate their lawns appropriately and not over-irrigate their lawns, we would save a lot of water. For consumers, there's definitely a cost and hopefully a benefit to making changes in the landscape. My colleague, Anna Thayer, an agricultural economist, is helping me conduct life cycle analyses of resource-positive landscapes.
Yeah, so starting in 2022, I'm going to be starting this project with Kelly, and I'm really excited to kind of dig in. My name is Anastasia Thayer. I'm an extension specialist and assistant professor in the Applied Economics department. So for this project, what we're going to be trying to do is thinking about grass as a technology. And so what economists really like to try to do is assess the benefits and costs of undertaking an investment or making a choice. We think about these choices all the time, right? For the decision to upgrade our cell phone, or if we're trying to buy a new car. Within that choice, we're thinking about, how much is it going to cost us today? How long am I going to use it? What is my upkeep going to be? And so we can think about that same decision-making framework and apply it to our lawns and to turf. And so in this case, we're going to think about our investment in grass and in turf is thinking about, how long is it going to take a homeowner to realize some of the benefits here. But for this project, we're considering a little bit more than that, right? We're trying to get to these broader community implications, as well as these, broader resource uses. And, we can start thinking about if, percentages of the community undertake this investment, what will some of the impacts be to water, to carbon dioxide emissions, things like that. Yeah, I was interested in USU and the Applied Economics department in order to stay working at a land-grant institution in a state that has a pretty strong agricultural economy, as well as some really interesting water issues and water scarcity issues.
Lots of technologies have seen major advancements in recent decades, and that's happened with grasses too. So with my own home lawn, I actually am always treating it like an experiment. And so I really, really, really push the limits in terms of how little water I can apply. Now I do try to maintain it at a point where I'm not losing any grass cover, but I do definitely push the limits in terms of water. And in addition to that, and something that actually helps with water, is I return grass clippings. I never take them off the property. I actually treat them as a tremendous resource because what they do is decompose, they provide nutrients to the existing turf, and they increase the organic matter content of the soil, which improves water retention. So I postpone that first irrigation each spring as long as I possibly can. So depending on the year, that might happen in May, might even happen in June. We've had quite a few springs that were very cool and very wet. So I push that first irrigation as long as I possibly can. And I also keep in mind that July is the month of the year where more irrigation will be required than any other month. And so at that time of the year, I'm certainly irrigating more than I am at other times of the year. My general approach to irrigation is deep and infrequent. I'm certainly not irrigating every day. I'm keeping an eye on the grass. I'm pushing its limits. So one of the really critical pieces of information we use in our research is weather data. And we have weather stations across the state, certainly at the Botanical Center and certainly at our research farm here in Logan, that we use to collect that data, and then that helps to inform our irrigation practices. I know it's easy to just turn on your sprinkler system in May and forget about it until the fall. But there are incredible technologies available to now, many of which are actually rebated by the state of Utah. For example, climate-based irrigation controllers. These controllers take real-time weather information and they allow or disallow irrigation appropriately depending on the weather conditions. I hope that people learn that their landscapes can actually provide a lot more than they take. They're not just sinks of resources, they can actually provide resources and help conserve resources. I hope that community leaders can really think about grasses in landscapes as virtual reservoirs, as a tool that can be used when times are dry, when more resources are needed. Developers and contractors can think of grasses as useful components of landscapes that can be specified in ways that will help to conserve water and still provide the ecosystem services that we'd like to see. I know it's easy for builders to just use the same materials they've always used, but with the advances we've had in turfgrass science, there are so many better options out there. The Research Landscapes production team has put together a packet of resources for you, and you can also find information at extension.usu.edu or seawell.usu.edu. As an extension specialist, it's my job to promote practices that maintain and improve the quality of life for Utah's leaders, developers, and citizens. I want citizens to know that they can have grass in their landscape, they can play on it, they can use it, they can have pets and kids running around, but they can still conserve water and they can still take great advantage of that grass to provide ecosystem services.